Hello. Um, I'm gonna kind of go through this practice test. This is in on campus in case you forgot where it's at. The answers are on here too. If you just scroll down all the way, they're the second half, right? So they're there for you. So the answers you should already have the answers, or at least most of the answers. But I want to go through pretty much everything as well as I can within reason, right? So I'm not going to reteach every single thing, but I'll at least be able to remind you of everything that we've done. All right. The one thing on here that wasn't on the practice test, or that will be on here that's not on the practice test, is the binomial expansion. All right, and I'll go over that, but just so we know, that will be a thing that'll show up on the test. All right, so I'll just go through this as best I can, and as you have questions, just either email me or put it in chat or whatever, and I'll do my best to answer them. Keep in mind there's a couple of second delay, right? So if I don't answer it immediately, just give me a second, and I'll try and answer it as best I can. All right. So we'll just go ahead and get started. Also, I guess before I get started, this isn't meant to be the only thing that you study, right? So if you're just watching me do these problems, you're not really studying, you're just watching me study. All right. But doing these problems is the best way to prepare for this test. All right. And keep in mind there's a bunch of examples throughout the last two topics that you can always go back and do, as well as your old test, which you all should have. All right. But anyway, number one and number two, those have to do with combinations, right? So whenever you see something in the form NCR, that's going to be n factorial over n minus r factorial times r factorial. All right, so if we had to show our work, we would set up 15 factorial over 15 minus 4 factorial, 15 minus 6 factorial. Times 6 factorial. And you can plug this into a calculator. You could plug this into a calculator if you wanted to. But we would get $5,005. Right, so remember 15 factorial. This is 1 times 2 times 3 all the way up until 15. Right, so that's 15 factorial. Then we have 15 minus 6, that's 9, so we have 9 factorial. And then times 6 factorial. And our job is to do all of this, right? So we have a bunch of products up top, we have a bunch of products down bottom. If you look closely, though, you should know that 1 all the way up to 9 cancels 1 all the way up to 9 down bottom. And then we have 10 times 11 all the way up to 15. All over 1 times 2 times 3 times 4 times 5 times 6. Okay, and if you do that, if you multiply all those out and divide it, you're going to get 5,005. Same thing for number 2. I'll do this a little bit quicker. So 21, choose 8. That's 21 factorial over 21 minus 8 factorial times 8 factorial. You could do it like I did up above, or you could go to a calculator. I believe that's in math. And then combinations, and there should be a combination button. If you click that, you should get something that looks like this. Fill those in, and it should give you the answer. So if we do this, 21, choose 18. We get 1330. Permutations are pretty much the same thing, except they have one less part. All right, so I'm going to erase some of this. So permutation NPR now. This is going to be n factorial over n minus r factorial. And that's it. Right, so there's no second part. So this is going to be, for number 3, this is going to be 7 factorial over 7 minus 3 factorial, which is 7 factorial over 4 factorial, which if we do this, these cancel out the ones up top, so then we're left with 5 times 6 times 7, which is 210. And then same thing for 5p4. That's 5 factorial over 4 factorial. And if you write it out like we did to the right, that's just going to be 5. Right, 5 factorial over 4 factorial. 1, 2, 3, and 4 factor up top and bottom. And then you're just left with 5 up top. So that's how you do those 4 problems. Will we have to show the canceling out for full credit, or do you just need the equation? I don't really, it doesn't matter. I'm just looking for the answers on these. For the previous test, I wanted you to show all your work, but I'm assuming that if you're able to get an answer, then you know how to do it. These are really just evaluate problems, so it's not a huge deal. These just show up in other areas a little bit later, and they're useful to know. All right, so that's combinations and permutations. 5 through 8 have to do with triangles, right? So we got to know SOHCAHTOA and a little bit of and Pythagorean theorem, right? So tangent, for number 5, tangent is opposite over hypotenuse. Okay, and we are given, not opposite over hypotenuse, opposite over adjacent. And we are given the adjacent side and the hypotenuse, right? So we have opposite and we need adjacent. And in order to find the adjacent, we would do 25 squared is equal to 15 squared plus the opposite squared. And when we do this, 25 squared that's 625. 15 squared that's 225. Solving for opposite squared, we would get 400. Take the square root of it. This is just going to be 20. So then we have 20 over 15, which is 5/3, 4/3. And again, I'm not looking for any of the work. Obviously, you have room there to do it, at least a little bit of room. But what I'm looking for here is the answer. Number 6, cosecant. So we have cosecant of theta. Theta, we are given the opposite side and the hypotenuse. And that's really helpful, right? So cosecant is hypotenuse over opposite. So this is just 17 over 8. And that's that. Number 7, sine is opposite over hypotenuse. And we are given both of those, right? So 16 is the opposite side, 20 is the hypotenuse. That should be 20. So if we do that, that's 8 over 10, so that's 4 over 5. Secant is hypotenuse over adjacent. We are given the adjacent side, and we are given the hypotenuse. So we're given both the things we need. So this is just going to be 10 over, 5 rad 5 over 10. Which is just rad 5 over 2. I'm going to differentiate these colors a little bit so we see. Well, no, I'll just leave it. All right. Number 9 and 10 have to do with converting radians to degrees and degrees into radians. Again, when we're converting degrees to radians, we're multiplying this thing by pi over 180. So really what this ends up being is 810 divided by 180, and then we're slapping a pi on. So we get 810 pi over 180. And then all we have to do is simplify. So that's 81 pi over 18. Which is negative 9 pi over 2. For number 10, this is in radians, so we want to multiply by 180 over pi. Pi's cancel. So we have 31 times 180 all over 6. Which is 930. Number 11. So number 11 and number 12, these are going to show up a little bit later too, but I wanted a couple multiple choice just as gimmies. Whenever we have a limit, for these at least, what we're going to do is we're just going to plug these things in, right? So if we're looking for the limit as negative sine of 2x approaches pi over 6, or as x approaches pi over 6 of negative sine of 2x, all we got to do is plug in pi over 6 for x, right? So this is going to be negative sine of 2 times pi over 6, which is negative sine of pi over 3. And this is where we go back to a unit circle. We need to know what sine of pi over 3 gives us. So pi over 3 if we have our unit circle, I'll try and open it up for us. So pi over 3. Try and zoom in a little bit. Maybe not. Pi over 3, that's up here, right? We're looking for the y value, which is just rad 3 over 2. Right, so this is going to be negative rad 3 over 2. That's our answer. So again, that's where I'm going to be requiring you to know the unit circle a little bit. All right, same thing for number 12, except we're not worried about a trig function. We're just trying to plug in x is equal to negative 3. So this is going to be negative 3 squared over 2 plus negative 3 plus 11 halves. This is going to be negative 9 over 2 minus 3 plus 11 halves. So that's 2 halves minus 3, which is negative 2. (13) and 14, this has to do with inverse trig. All right, so on number 13, this is our angle. We are given the opposite side and the hypotenuse. Okay, so we have an opposite side and hypotenuse, so we know that we can set up the trig function for sine. So sine of theta is going to be equal to 10 over 14. In order to find the angle theta, we want to use a little bit of inverse trig. So what we're doing is we're taking the inverse sine of both sides. These sines cancel out. So we have theta is equal to the inverse sine of 10 over 14. And then we plug this into a calculator and get an answer. So we're going to get $45.6. Same thing for number 14, right? We have this angle theta. We are given the opposite side and also the adjacent side. So now we have opposite and adjacent. So we can set up a tangent function. So tangent of theta is going to be 15.3 divided by 14. Again, we take the inverse tangent of both sides. So we have theta is equal to inverse tan of 15.3 divided by 14. Plug that into a calculator, and we can get an answer. Which is going to be 47.5. (15) and 16 are very, very similar to 13 and 14. Except now we're trying to find a side. All right, so on number 15, we have this angle, this 63.3 degree angle. We have the hypotenuse, and we have the adjacent side. Or we're trying to find the adjacent side. So we're going to have an adjacent side and hypotenuse, so we're going to be able to set up a cosine function. So we know that cosine of this angle is going to be equal to x over 7. So in order to get x by itself, we have to multiply both sides by 7. So we'd get 7 times the cosine of 63.3. We'd plug this part into a calculator and multiply by 7. And then we're going to get our answer. Which is going to be 3.15, or 3.1, I guess. Same thing for number 16. Number 16, we are given this angle. We are given the opposite side, and we're given the hypotenuse. Okay, so we can set up a sine function. So sine of this angle 41 is going to be equal to x over 14. So in order to get x by itself, we multiply both sides by 14, so we get 14 times the sine of 41. And that's going to give us (9.2). That's all we have to do. All right. And while people are maybe looking that over, these 16 questions, these multiple choice questions, aren't meant to be incredibly hard. They're just meant to be evaluation problems. So they're just really quick things that we need to know how to do. And that's that, right? I'm not looking for all of this work. I'm looking for you to quickly kind of plug it into a calculator and be able to go. If you need to show a little bit of work, that's fine. But the idea here is to kind of get these pretty quick. These multiple choice are each going to be worth 2 apiece. All right. So we need to be thorough, but these aren't going to be the majority of the test. This is about 1/4 of the test. All right. So that's a multiple choice. The next couple of problems are a little bit more involved, or they progressively get more involved, right? So determine the sequence is arithmetic, determine if the sequence is geometric, and then write the explicit formula. These are all the stuff that we did last test, all right, which most people did really, really well on, so this shouldn't be a problem. Determine if the sequence is arithmetic. If it is, find the common difference and the explicit formula. So there's 2 different things, well, 3 different things. First, determine if it actually is an arithmetic sequence, right? Which we can pretty easily see that number 17 is. Right, we have to add 100 to each of these to get to the next. So that means, yes, it is an arithmetic sequence, and the common difference is 100. Right, so realizing that it is a arithmetic sequence, that's worth 1 point. Finding the common difference, that's another point. And then finding the explicit formula, the nth term, that's another. Right, so the nth term is going to be n minus 1 times the common difference plus the first term. So in this case, it's going to be n minus 1 times 100 plus -7, so -7. And this is what I'm looking for. You can simplify this if you want, but that's all you need. Number 18, looks like we're subtracting 10 from each. So yes, it is arithmetic, and then our common difference is -10. So that right there is just worth 2 points, like realizing it is or it isn't, and then actually giving me the explicit formula. So in this case, the nth term is going to be n minus 1 times -10 plus 12. Those are the arithmetic sequences. Number 19 and 20 have to do with the geometric sequences. So in order to get from here to here, we would have to multiply by -5. From here to here, we'd also have to multiply by -5. And then from here to here, also -5. So yes, it is geometric, with the common ratio being -5. And the nth term for a geometric sequence is going to be the first term times the common ratio to the power of n minus 1. So in this case, this is going to be 2 times -5 to the power of n minus 1. Number 20, in order to get from this first term to the second term, that's times -6. -24 times -6. Gives you 144, so this is being multiplied by -6. And I believe this is as well. Okay, so this is still going to be geometric with common ratio being -6. That means the nth term is going to be the first term times the common ratio to the power of n minus 1. Hi, Lally. Number 21 is a little bit more, I guess, it's not arithmetic and it's not geometric. It could be either one or it could be something entirely different. But your job is to find how to get the explicit formula for this sequence, right? So we go 3 to -6, -6 to 12, 12 to -24, and -24 to 48. It already looks like we're multiplying by -2. All right, so let's try that. So this looks geometric to me, where our first term is 3, our common ratio is -2, and then this is going to be to the power of n minus 1. So we should be able to check this. So if we plug in 1, we should get 3. And that's true. If we plug in 2, we should get -6. -2 to the first, that's just -2. -2 times 3 is -6, so that works. And then we can check one more. -2 squared, that's 4. 4 times 3 is 12, so that works. So then this is our nth term. Okay, this is geometric. It might not be on the test. Okay, we've had a couple of examples where this isn't necessarily geometric. I wouldn't plan on it. It might be, but it doesn't have to be geometric or arithmetic or an arithmetic sequence to be in this problem. Just to be aware of that. Is guess and check the only way to do these? Not really. Like it is kind of. That's kind of how I do it, but you also need to recognize patterns. Like even as I was just listing 3, -6, 12, 24, 48, I could tell we're being multiplied by 2 in some way. But we also have to keep in mind that we're going first term. So if we plug in 1, we should get 3. If we plug in 2, we should get -6. If we plug in 3, we should get 12, and so on and so forth, right? So we might be able to get it recursively, but we're looking for an. So there's a little bit of guess and check involved, but it's really up to you to kind of determine what that looks like. All right, so those are the sequences. Again, arithmetic, geometric, and any. Now we get to the graphing parts. All right, and just so we see this, I want to make sure I get my points right. Okay, so like I said, the multiple choice were each worth 2 apiece. These arithmetic sequences, actually pretty much each of these are worth 3 apiece. Okay, so the arithmetic are each worth 3. The geometric are also each worth 3. Right, and I'm going to scoot back up here. 1 point for realizing it actually is arithmetic or not. 1 point for the common difference, and then 1 point for the explicit formula. And that's on both 17 and 18. Number 19, kind of similar. Realizing it is geometric, finding the common ratio, and then finding the explicit sequence. And then same thing for 20. Number 21 is going to be worth 4 points. And that's really for just, it depends on where you're at in your work, but it's being able to get from the first 1 to the first term, 2 to the second term, 3 to the third term, right? So depending on how close you are, you're going to get different amounts of points. All right. Number 22, I will just say this: these are being graded very, very similar to the way I graded them on the Trig test. So this is going to be worth 12 points. and this is going to be worth 10. Okay, so these are quite a bit. All right, so 22. Again, this is almost directly from the last test and the couple of homeworks we did. We have to find a vertical shift. In number 22, there is none. We have to find an amplitude. In this case, it's 4, right? It's the thing being multiplied by the sine function or cosine function. We have to find a start point. And if we think about a unit circle, right? This initial angle, right, is 0, right? So any angle where it makes the entire inside 0, that's where we're going to start. Okay, so we set the inside equal to 0, and we solve. So in this case, theta is just 5 pi over 6. And I'll just say this. Each of these steps is worth a point. In the end, right, if we rotate all the way around this circle, that's going to be 2 pi. Right, so that's our ending angle. So theta minus 5 pi over 6 is going to be equal to 2 pi. So then theta is equal to 2 pi plus 5 pi over 6, which is the same as 12 pi over 6 plus 5 pi over 6, which is 17 pi over 6. And then finally, our period, that's just our end minus our end minus our start. So 17 pi over 6 minus 5 pi over 6, which is 12 pi over 6. Okay, so that's our starting work. Right, so before we even graph, there's 5 points available. I'm going to make this a little bit smaller just so we can see everything. All right, so now we graph it. All right, so one of the remaining points is just the shape. So we have to know that sine kind of does the wave from the start. Okay. Another one of these points is, so one is the shape. I'm gonna put that in the inside. And then one is for setting up the amplitude in the starting position, right? So our vertical shift, that's 0. Our amplitude says we go up 4, and it says we go down 4. And then the rest is just setting up different points, right? So one is setting up that, one is the shape, and then we set up the remaining points. All right, so we have the start and the end. Our start is 5 pi over 6. So this is going to be 5 pi over 6 comma 0. Our end is 17 pi over 6. So this is going to be 17 pi over 6 comma 0. And then we have to find our center point, our max, and our min. In order to find the minimal, the middle, we're going to average these two. Right, so 17 plus 5, that's 22. 22 divided by 2, that's 11. So this is going to be 11 pi over 6, comma 0. And then we do that kind of the same way, but for the outside points. So, right, so this max, that's going to be 5 plus 11 divided by 2. So that's 16 divided by 2, which is 8. This is going to be 8 pi over 6, comma 4. And then 11 plus 17, that's 28. 28 divided by 2, that's 14. So this is 14 pi over 6, comma negative 4. Right, so each of those points is worth another point. Right, so that's a bigger problem. Right, for number 23, what we need to do is we need to graph cosecant now. All right, so the first thing you should realize is that in order to graph cosecant, it's easiest to graph sine. So what we're really trying to graph is this. And then we have to add on a little bit at the end. Okay, so we still have to find the vertical shift. In this case, that's -1. That's this part right here. Our amplitude, that's the thing being multiplied by the trig function, which is 2. We still have a start point. So we set everything inside parentheses equal to 0. For our endpoint, we set everything inside parentheses equal to 2 pi. And then we still find the period. So we subtract the end from the start, or the start from the end. This is going to be a little bit awkward, just because it's an odd number. So, I guess before I graph it, one point for realizing you're actually graphing the sine function. Right, so for just understanding that cosecant is going to be like sine, that's worth a point. All of this stuff is going to be worth 4 points. And then the next 5 all has to do with the graph. So if we start to graph this thing in orange, I think it's 5 pi over 3. What is 5 pi over 3? So we're talking about the end. All right, so if we redo this, I'll just redo it. So we have theta over 2 is equal to 2 pi plus 5 pi over 6, which is 12 pi over 6. I'm not sure where. Yeah, I'm not sure what you're talking about, Jack. Because then theta would still be 17 pi over 3. Well, regardless, we can still graph it. So in orange, what we're going to do is we're going to graph the sine function. Again, the shape of this is important. Oh, I see. Ah, okay. Okay, I got it. So that should be 3. All right. Sorry about that. So this should be theta over 2 minus 5 pi over 3. All right, so this changes a little bit. That's okay. So we have theta over 2 equals 2 pi. And then I'm just going to, so we're going to add 5 pi over 3. So this needs to be 6 pi over 3. So theta over 2 is going to be 11 pi over 3. So theta is 22 pi over 3. Which means the period is going to be 12 pi over 3. So 22 pi over 3 minus 10 pi over 3. So that's our period. Thank you. All right. So then So then we do the graph as normal, right? So our center line is going to be -1. Our amplitude, that tells us we go up 2 to +1, and tells us we go down 2 to -3. Our start point is going to be 10 pi over 3 comma -1. Our end point is going to be 22 pi over 3 comma -1. Then we're going to do the same thing. So 10 plus 22, that's 32. 32 divided by 2, that's 16. Ten plus 16, that's 26. 26 divided by 2, that's 13. And then 16 plus 22, that's 38. 38 divided by 2, that's 19. Okay, so these are all of our points, but what I really want us to understand is that this is where the shape comes, this is where the other 5 points comes in. Where we cross the center line, that is going to be a vertical asymptote. And then we have one along our original line. Okay, and then we draw up from the maximums and down from our minimums. And that's the graph. Okay, so the part in red is what I'm really grading you on. But those points matter because our asymptotes are going to be 16 pi over 3, 22 pi over 3, and 10 pi over 3. And then our critical points are going to be 13 pi over 3 and 19 pi over 3. So those are all still really important. It just tells us different things about the graph. Okay, I think we did that a lot in class, and we practiced that a lot, and we tested on it. So I think we should be comfortable with that, or at least mostly. I know that's a lot, but that's what that is. Okay. So moving on. Then we have to find the graph of y is equal to 1/2 tangent of theta over 3 minus pi over 6. All right. So again, if we think about a unit circle, tangent is going to be the ratio, is going to be the y value over the x value, right? So we're going to have asymptotes when x is going to be 0. And theta is going to determine that, right? So x is going to be 0 at this point and at this point. And that angle is going to be pi over 2 and also 3 pi over 2. So what we need to do is we need to find those asymptotes. So we are going to have asymptotes when our angle, the thing inside, is equal to pi over 2. And we can solve the next one. So theta over 3 is equal to pi over 2 plus pi over 6. Then theta is equal to 12 pi over 6. Can we have a note card for the final? No. So this is one asymptote. And then the other one is when it's equal to 3 pi over 2. I'm going to save a couple of steps. No, I'm not. Okay, so we have two asymptotes. So now what we need to do is graph it. So we have two asymptotes. We have 12 pi over 6. And then we have one at 30 pi over 6. And our graph, our tangent graph, looks a little bit like a cubic, but not quite. And our final kind of job here is to find the center point. And that's just the average of the two asymptotes. So 30 plus 12, that's 42. 42 divided by 2, that's 21. This is going to be 21 pi over 6. And then comma our vertical shift, which is just 0. All right, so I guess I should have done that. Vertical shift here is 0. Amplitude, which doesn't really matter in this case, is 1/2. talking points, this entire thing is worth 6. 1 for finding each of these. And then the rest for setting up the graph, right? So yeah, the remaining is just 4. Right, so this entire thing is worth 6. I think I did 1 for the center point, 1 for setting up the asymptotes, each of the asymptotes, and then 1 for setting up like the graph or whatnot. You would use 0 and pi for cotangent. I'll just go ahead and tell you I'm not going to give you cotangent. You're right, but I'm not going to give it to you. I don't think we spent enough time on it. It's the same thing. We didn't talk about it a whole lot, so I feel bad about giving it to you. You're right, because sine would be underneath, right? So then we'd be seeing when the sine is 0, which happens here and here, which is 0 and pi. All right. So now we get to the fun stuff, right? So verify each identity. So I'm asking you to verify that the left-hand side is equal to the right-hand side. So we have to know those identities still. So I'll write the Pythag identities out, because I think these are what people get confused most about. So we know that sine squared of our angle theta plus cosine squared, that's always going to be equal to 1. If we divide both sides by sine, we get 1 plus cotangent squared of theta is equal to cosecant squared. If we divide both sides of our original by cosine, we get tangent squared plus 1 is equal to secant squared. Right, so those are the 3 that are a little bit harder to comprehend, but that's why. And sine squared plus cosine squared comes from the Pythagorean theorem. Okay, our job though is to verify that the left-hand side is equal to the right-hand side. So I guess before I start, each of these are worth 4, just kind of depending on how far you get and your logic, right? So even if you don't get it right, normally I give points just from doing stuff, right? It's so long as you're actually using identities, all right? But what we can do is we can do sine squared times cosecant squared. We should know that cosecant squared is 1 over sine squared. And you don't have to worry about the variables. I just want us to be able to kind of do this kind of math. All right, sine squared times 1 over cosine squared, that just becomes 1. And then you have 1 plus tangent squared is equal to secant squared. And that's an identity, right? So secant squared is equal to secant squared, and that checks out. '26, I'm sure there's a bunch of different ways, but I haven't actually done this yet. So I'm going to do the one that I would think is right. I should make them that simple on the actual exam. Normally they are. I don't think none of these identities are super incredibly hard. You just got to be able to find like 1 or 2 things that work and then go with it. The one on the trig test was too much. I didn't think it was that bad. Could I leave it as that identity? So you're saying, could you get to here? I would rather you get to this spot just so I know that you know that that's an identity. If it comes to that. I would like you to explicitly state that the left-hand side is equal to the right-hand side using those identities. I know it seems like one extra step, but it's helpful. All right, so number 26, I'm going to write this as 1 over cosine squared plus 1 over sine squared over, I'm going to write this as 1 over sine. I might not need to. So that's all the left-hand side. And if we look at the left-hand side and try and add these two things, we have to multiply the left fraction by sine squared over sine squared, and the right one by cosine squared over cosine squared. And when we do that, we would get sine squared over sine squared cosine squared plus cosine squared over sine squared cosine squared all over 1 over sine. Will I take points off if you don't do the extra step and simplify? For UMax, yes. So we can add these two fractions because they have a common denominator. So this is sine squared plus cosine squared over sine squared cosine squared all over 1 over sine. Sine squared plus cosine squared, that's an identity. So then this is 1 over sine squared cosine squared divided by 1 over sine. So when we divide by a fraction, we're really multiplying by its reciprocal. So this is going to be equal to 1 divided by sine squared cosine squared times sine over 1. This sine cancels one of these sines. And then you have 1 over sine cosine squared, which we can split up into 1 over sine times 1 over cosine squared, which is going to be secant squared. And then we have then we have secant squared over sine. Again, there's probably an easier way to do it. That's just the way I chose. What type of dog do I have? It's an Airedale. She's an Airedale. It's Phoebe. Phobes for short. All right. So this is the identity problems. And then the rest is stuff that, well, most of the stuff is the stuff that we just did. So before I do these, each of the log problems are worth 4. Again, it kind of just depends on how far you get. Can that be an extra credit question on the test? Nah, no, it's fine. You'll be all right. I've got faith. All right, so logs. We have 2 logs on one side, so we have to combine them. So we have to combine them. So we have log base 6, right? So we have the product of 2 logs of the same base, which means we multiply the inside. So we have log base 6 of 9x squared plus 72 is equal to 3. In order to undo the log base 6, we take everything as an exponent of 6. And what we do to the left-hand side, we have to do to the right-hand side. Right, so these cancel. And we're left with 9x squared plus 72 is equal to 6 cubed on the right. 6 cubed is 216. And then you just solve this like any other problem, right? So 9x squared is equal to 216 minus 72 That's 144. So x squared is 144 divided by 9. Take the square root of that. So x is 12/3. .28 is kind of like the reverse of that problem. Right, so now we have an exponential and we got to solve it. So we would divide both sides by 9. So we have 10 to the power of a plus 2 is equal to 20 over 9. In order to undo this exponent of 10, we have to take log base 10 on both sides. All right, what we do to one side, we have to do to the other. This log base 10 and that exponent of 10 cancel. So we have a plus 2 is equal to log base 10 of 20 over 9, which means that a is equal to log base 10 of 20 divided by 9 minus 2. And before I do the next couple problems, each of these are worth 3. And these are going to be pretty similar to the multiple choice ones, except for 31 and 32, right? So number 29, all we're doing is we're plugging in negative pi over 3. So this is going to be 2 times sine of negative 2 pi over 3. And if we go back to that unit circle, negative 2 pi over 3, so that's going down 2 pi over 3, so 1 pi over 3, and then 2 pi over 3. Sine of negative 2 pi over 3 is negative rad 3 over 2. So then our answer is just negative rad 3. Same thing for number 30. This is going to be 2 times sine of negative 2 pi over 3. It's the same thing. Yeah, it's the same thing. So this is going to be negative rad 3 again. I wouldn't count on that, but that's what it ended up being right now. So it's basically finding x but complicated. Wouldn't there be a negative? I think all that's right. And yeah, it's basically finding x but complicated. But that's all of math. Actually, all of math is more like the identities. This is just evaluating stuff. All right, moving on. Number 31, if we plug in 2 into our entire limit, we would get 0, and then we'd get 4 minus 14 plus 10. So we'd get 0 over 0. Okay, that means we have to do something to this entire fraction so that we can actually take this limit. All right, so what we can do is we can try and factor the top and bottom. There's nothing to factor on top though, so that's just going to stay the same. The bottom, we need factors of 10 that add up to negative 7. So let's try x minus 5, x minus 2. You should notice that x minus 2 is a common factor. So this is going to be the same thing as the limit as x approaches 2 of 1 over x minus 5. Now when we plug in 2, this works. So we just get negative 1/3. Can I explain how to get negative 2 pi over 3? You're just going reverse. Okay, so you're going down. I know you said you got it, but it's probably a good thing to look at. Right, so normally, like this is pi over 3, and like this is 2 pi over 3. Well, we're going the opposite way. So negative pi over 3 is like down here, and then negative 2 pi over 3 is like down here. So you'd be looking at this point right here, which I think is negative 1/2, comma negative rad 3 over 2. And that was the point we're looking at. All right, number 32. Again, if we plug in 1, we would get 0 over 0. So that means we have more work to do. There's nothing to factor. Right, we can't factor out the x minus 1s because one of those is under a radical. But what we can do is we can try and rationalize. And what I mean by that is we're going to try and cancel out the square root of x minus 1 in the denominator. And in order to do that, what we're going to do is we're going to multiply by the conjugate of the denominator over itself. And the reason why we do that is because whenever we multiply something by its conjugate, we get the difference of squares, which is going to cancel out our square roots. So what we're going to get is the limit as x approaches 1 of, I'm just going to leave this as factors because there's no reason to multiply it out. So that's the numerator. All right, that's just like what we have up top. And then the denominator is the difference of the squares in denominator. So this is going to be x minus 1. But that doesn't do anything. Oh, yeah, it does. So now there's a common factor on top and bottom. Those cancel each other out. So this is the same thing as asking for the limit as x approaches 1 of the square root of x plus 1. And then we just plug in 1. So we get the square root of 1 plus 1, which is 1 plus 1, which is 2. So that's 32. Okay. 33 and 34 are taking the derivative. All right. So the definition of a derivative again, it's finding the slope of things that are really, really close together, such that we're basically taking the slope at a point, right? And in order to do that, what we do is we take the limit as h approaches 0 of f of x plus h minus f of x all over h. And we derived this in class. Again, it's just taking the slope of 2 points really, really close together. But this is really, really important. That's going to be really important next year too. Okay. So just knowing this and being able to kind of apply it in 33 and 34, or at least trying to apply it in 33 and 34, that's worth credit. All right. So before I start, each of these are worth 5 points. okay? And one of those is always going to be using that definition in some way, shape, or form, right? So even if you just list it, I'll probably give you credit. But what I mean by that is actually using the f of x plus h and minus f of x, right? So if we do this on this problem, on number 33, right, f of x is 2x squared plus 5x minus 4, right? So if we're taking the limit as h approaches 0 of f of x plus h, that's going to be 2 times x plus h squared plus 5 times x plus h minus 4. And I'll probably do this other problem somewhere else just for room. And then we're subtracting the original f of x. So we're subtracting 2x squared minus 5x and then plus 4. And we're taking all of this over h. And then what we're really trying to do is we're trying to cancel things out. So this is going to be the limit as h approaches 0 of 2x plus h squared is x squared plus 2xh plus h squared, and then plus 5x plus 5h minus 4 minus 2x squared minus 5x minus 4. And again, all of this is over h. If we distribute this 2, we get 2x squared plus 4xh plus 2h. That should be squared. Plus 5x plus 5h minus 4 minus 2x squared minus 5x minus 4 all over h. That seems like a lot. All we're doing is foiling and distributing. But what you need to understand is that, so what did I do here? These should be plus 4s. Right? Those should be plus 4s. Okay, so what we're trying to do here is we're trying to cancel things out. Okay, so we should see that 2x squared and negative 2x squared, those cancel. Negative 4 and positive 4, those cancel. And then positive 5x and negative 5x, those cancel. So then we have the limit as h approaches 0 of 4xh plus 2h squared and then plus 5h all over h. And again, if we plug in that h, we're going to get 0 over 0. What we can do is we can factor an h out from the top. So this is the limit as h approaches 0 of h times 4x plus 2h plus 5 all over h. These h's are common factors, so they just divide each other and become 1. So then we have the limit as h approaches 0 of 4x plus 2h plus 5. And when we plug in h is equal to 0, we just get 4x plus 5, and that's our answer. Again, I understand that's a lot. But it's more just like algebra work. It's not like, I don't think much of this is like critical thinking work. All right. And again, you're going to get points depending on where you get to, but like this first step is definitely going to be worth 1 point. And then the right answer is definitely going to be worth 1 point. The rest is like canceling and being able to foil and factor and stuff. But that's how that's going to work. All right. Last question, at least on the practice test. I'm going to make this smaller. Same thing, right? We have the limit as h approaches 0 of f of x plus h. That's going to be rad 4x plus 4h minus 2. So is there only these 34 questions on the test, or will there be more? There's going to be one more. It's going to be the binomial expansion problem. Right, so this setting up, that's worth credit. All right. That should be an H, not a 2. But if we plug in, we get something over 0. In fact, we get 0 over 0. So we need to be able to do something about this, right? And in this case, what we're going to do is we're going to multiply by the conjugate. We're going to try and like kind of reverse rationalize. Yes, I'm going to do an example of that. So again, what we're going to try and do is we're going to try and rationalize this out. We're going to use that difference of squares in order to maybe hopefully do something. Okay. So when we do this, we get the limit as h approaches 0. When we multiply this part by this part, we get the difference of squares, right? Those are conjugates of one another. So we get 4x plus 4h minus 2 minus 4x minus 2. So we get minus 4x and then plus 2. All over h times that factor. So square root of 4x plus 4h minus 2 plus square root of 4x minus 2. So when we do this, things are going to cancel. So 4x cancels negative 4x, negative 2 cancels positive 2, and we're just left with 4h on top. So now this is that the limit as h approaches 0 of 4h divided by h times that factor. There's a common h. And now this is the limit as h approaches 0 of 4 divided by that factor. Oops, not that big. These should be h's. I don't know why I keep making those x's. All right, and when we do this, so we just plug in 0 for h. So what we're going to get is we're going to get 4 over 4x minus 2, square root of 4x minus 2 plus the square root of 4x minus 2. So we get 2 of those. And then this can be your answer, but if you simplify this, this is 2 over square root of 4x minus 2. Again, you can get here. I'm not really worried about that. And then that's the entire practice test. Okay, so I hope I gave good explanations. I want to do one more problem about the expansion, right? So let's say we want the expansion of this expansion, and we want, let's say, the third term. there's a couple rules that we went over in class. But basically, we're going to have the first term to some power times the second term to some power. And we're going to have some combination. And then that'll be what we're trying to find. All right. So we're trying to find the third term. Because it's to the power of 6, right? The first term is going to be 3x squared to the 6th. The second term is going to be 3x squared to the 5th. And then the third term is going to be 3x squared to the 4th. Okay, so that's going to be our power. And then the remaining, right? So 4 plus something has to be equal 6, so the remaining is 2. You could also look at it as the second term is going to start with the power of 0. The second term is going to be the power of 1. And then the third term is going to be the power of 2. I hope that makes sense. We're basically counting down from 6, right? So first term to the power of 6, first term to the power of 5, first term to the power of 4, and then that's our third term. Or you can look at it the same way. Second term to the power of 0, second term to the power of 1, second term to the power of 2, right? That's where the 4 and the 2 come from. Okay. And then our combination is the x variable always going to be the one that counts down. It's not necessarily the x, it's the thing in the first position, right? So it's always this thing that's going to be counting down. And it's always this thing that's going to be counting up. Right? That's why, right, this is the first position. This is the second position. The first position counts down, the second position counts up. Okay. And then we need our coefficient. So we need something, choose something. Right? So if we look at this, there's going to be 6 of those to be multiplied together. And we are choosing 4 of them. Right? So there's 6 and we need to choose 4. So 6 choose 4 is going to be our coefficient. Right? So that's most of the credit. The rest is just you trying to do 6 choose 4. Really. So 6 factorial over 6 minus 4 factorial times 4 factorial. So it's 6 times 5 over 2, just 15. I think that's right. Yeah. Yeah. And then the rest is just, we can just leave this. I'm not really worried about you simplifying this. And that can be our answer. I'm going to be looking for a couple things. That question is going to be worth 6 points, so it's a bit. Can't probably see that. We're going to get 1. I'll do this in teal. All right. So the first is getting this part. The second is getting the second term. All right, so this is worth 1. Second term is worth 1. These powers are each worth 1. So that's 5 points. And then being able to do this combination, that's worth 1. Okay, so overall, this entire test is a whopping 120 points. Okay, I will most likely do something to help you out, right? I am probably going to give you a unit circle just because this is a lot to take in. And then I'll probably add on a couple points. So I'll probably take this out of 125 or something like that. But right now it's out of 120. So this is a lot of points. This is a lot of stuff to know. But I hope that this can kind of guide you about what you need to review and about what you need to, or what you don't need to review as much. Okay. So I'm going to leave this open for like a minute or two. And I'll answer questions all night if I have to. But if there's no questions within the next couple minutes, I'll shut this down. And I'll email the link out to this so it's there and it's visible. But if there's no questions in the next couple minutes, I'll shut it down, and I'll see you tomorrow. Okay. Where did the 15 come from? 6 choose 4. All right, so 6 choose 4, I think is 15. That's 6 factorial over 6 minus 4 factorial. That's 2 factorial times 4 factorial. So we're left with 5 times 6 up top over 2. 5 times 6 is 30. 30 divided by 2 is 15. So this gets you that. I'll think about it. It's kind of hard when you combine it with limits, so I probably will. I just got to make sure to print it. All right, so I'm going to mute myself, and I'll take any questions. Again, please ask. That's what this is for. So. You're welcome, David. And Henry and Jack. All right, so I'll throw out a 2-minute warning. Okay. It doesn't seem like there's any questions. So I'm going to shut this down. If you do have questions between now and our test, I'll definitely take questions like in the middle period or whatever. And if you find me in the morning, or if you need questions, email me and I can make sure to be there in the morning to help you out. I'm going to be proctoring an exam first period tomorrow, so won't necessarily be in my room like right before that bell. But I can try and be there if people need help. All right. So I will shut this down. Good luck tomorrow. And again, if you have questions, please let me know.